Hello, Math 1050. This is section 5.2, Systems of Linear Equations in 3 Variables. So continuing to work with systems here, but this time we'll have 3 variables and 3 equations. So last time we talked about that if we had a system of 2 equations with 2 variables, we can think of it visually as 2 lines, and we're searching for their intersection point if it exists. Well, now that we're working with 3 variables, if you wanted to think about what that would look like, an equation with 3 variables represents a plane, like a piece of paper, and we're looking for a point where 3 planes intersect. So you don't have to graph planes or anything like that. It's just, I think, interesting to see visually what we're looking for. So here is our 3x3 system that we're going to start with. So we've got 3 equations and 3 variables, x, y, and z. So what we're going to do to solve this system is use elimination. And you want to pick a pair of equations that you can eliminate one of the variables. So to keep track of things, to stay a little bit more organized, I'm going to just label these equations as A, B, and C. So I'm looking at the variables, and what I would do is kind of look at the coefficients and see which one you think would be the easiest to eliminate. And, there's a valid case for any of them, but just for fun, I'm going to eliminate y. And again, there's nothing special about why I picked y in particular. You could choose x or z to eliminate, but pick one of them to eliminate. So I can see that if I add together equation A and equation B, that the y would be eliminated. So I'm going to go ahead and do that. I'm going to add together equation A and equation B. So if I do that, and since they're just together, I don't need to rewrite it or anything, negative x plus 2x gives me 1x, 2y plus negative 2y gives me 0y, 2z minus z gives me 1z, and then 7 plus negative 6 gets me 1. So I now have an equation that just has an x and a z in it. It doesn't have a y. So now what I want to do as my second step is I want to pick another pair of equations, and I want to also eliminate y. You want to eliminate the same variable both times. So I'm going to pick A and C. So here's C down here at the bottom, and I'm going to also choose A. I could have also chosen B and C if I wanted to. The reason that I chose A and C is because in A, the y coefficient is positive, and in B, the y coefficient is negative. So I kind of like to have those opposing signs. So I can't, if I just add together A and C, it wouldn't eliminate the y. So I'm going to multiply A by 2 so that this is a coefficient of 4. And then if I add it to equation C, then it will eliminate. Now I'm going to rewrite this one because I'm doubling A. So 2 times A is, sorry, let me move this down a little bit. Okay. 2 times A is negative 2x, and I'm multiplying the whole thing by 2, so this is a 4y and a 4z, and it's equal to 14. Don't forget to multiply that constant by 2 as well. And just to make it easier to see what's happening, I'm going to go ahead and write C underneath. So there's 2A and C, and I'm going to go ahead and add those together now. And if I add those together, I get x. Negative 2 plus 3 is 1x. The y's eliminate. My z is 2 coefficient. And 14 minus 9 is 5. Okay, so I eliminated y twice, and I ended up with this equation and this equation. Both of those equations have two variables, x and z. So we are going to use these two equations to solve for x and z. And this would be just what we did in section 5.1. So I think I would like to just do another quick elimination here. So the equation I just got was x plus 2z equals 5. I'm going to multiply this first equation by a -1. Negative x minus z equals -1. And now I'm going to add them together so that x cancels out. I've got z is equal to 5 minus 1 is 4. So I've solved for z. Okay, so I've got z. Now, once you find your very first, I guess, solution value, we still need to find x and y. We have z now. So you're going to just go back one step each time. So if I think about that equation that was a plus b, I know that x plus z is 1. Well, z is 4, so x plus 4 is 1. So if I subtract the 4, I get that x is -3. I could have chosen to use this equation to find x as well, and I should get the same answer. And then to find the last variable, you have to go back to one of your original equations. I'm going to use that very, very top equation right there. So if I substitute in my -3 for x plus 2y, and I don't know y, so the y is still going to stay there for now. And then I'll substitute 4 for z. That's equal to 7. So -3 is +3 plus 2y plus 8 equals 7. So I've got an 11 over here. I have a 3 and an 8. So I'm going to subtract those, and that together they're an 11. So I get 2y is equal to -4. So I divide by 2, and I get that y is equal to -2. So choose one variable to eliminate twice, use those two equations to start building your solution, and then you just keep subbing back in until you get to your final answer. So like 2x2 systems, sometimes these have one nice answer that you can find. Sometimes they have no solution, and sometimes they have infinitely many solutions. Infinitely many solutions would be if all the planes are the same. No solution can happen a couple of different ways. The planes might sort of create this triangular prism where they don't all intersect. The planes could be parallel, or two of the planes could be the same, but the third one parallel. Anyway, you don't have to know the three-dimensional shapes or anything, but it's interesting, I guess, to think about. So this first system that we're going to do, I want to show you, I already showed you how to find a unique solution, so we're not going to do that again, but I want to show you what it looks like if you have no solution or if you have infinitely many solutions, because especially the infinitely many solutions is a little tricky. So we're going to do no solution first. So this is a system that has no solution. So we are going to, let's see, I'm looking at these. I'm thinking the easiest one to eliminate is going to be z. And I'm always just looking to see which variables would be the easiest to multiply to get the same coefficient. I think x on this one would be pretty easy as well, but I'm going to choose z. So let's first just add together equation A and equation B. And if I add those two together, I get x plus 2y is equal to 3. And I'm trying to eliminate z, so looking at I need to use C now. C has a 2z, so I'm going to times b by 2 so that the z coefficients will add to 0. I'm just going to write the 2b underneath C. So timesing b by 2, that will be a negative 2x plus 10y minus 2z is equal to negative 2. I almost can't write that small. Okay, so we're going to add together these two equations, C plus 2b. Oops. So 5x minus 2x is 3x. 4y plus 10, negative 4y plus 10y is 6y, and 9 minus 2 is 7. Okay, so we've got our system down to 2 equations and 2 variables. So let's see, I think let's eliminate the x. So I'm going to times this one by negative 3. And I'll write it underneath. Negative 3x, negative 6y, and negative 9. So now if I add these two equations together, I get 0 equals negative 2. And that is a false equation, and false equations mean that there is no solution. Okay, last one. I need to show you how to deal with a system that has infinitely many solutions. So let's look at infinitely many solutions. We've got this system here. I think looking at these coefficients, I think that I want to eliminate the x. So let's label it A, B, C. We can go ahead and add together A and B. When we add together A and B, we get the x eliminates, 2y minus y is y. We've got 2z, and it's equal to 3. So I need to eliminate x with another pair. I think let's multiply b by 2, because then we can have an elimination here with our x. So I'm going to multiply b by 2. Negative 2x minus 2y plus 10z is equal to negative 2. Don't forget to multiply the number at the end. So let's add together 2b and c. So if we add together 2b and c, we get 3y plus 6z is equal to 9. So we have a system of 2 variables with 2 equations here. So let's try to eliminate our y now. So I'm going to multiply this one by negative 3 and write it underneath. So this is negative 3y minus 6z is equal to negative 9. When I add those together, I get 0 equals 0. This is true, which means that there's infinitely many solutions. So when you look at where it gives you the choice of infinitely many solutions, it wants you to type into these boxes. You're going to pick one of them, and then you have to fill in the 2 boxes. Now, it honestly doesn't really matter which of these you choose, but whichever one you choose will affect, what goes in those other 2 boxes. So what I usually look for is I look for an equation that is easy to solve for one of the variables. So I guess I'm not looking at these original equations. I'm just looking at these 2 equations right here. And I want to think about which one is easiest to solve. And if I'm looking at these and thinking about which variable is the easiest to solve for, I think it's y. Everything else has a coefficient, right? Whoops, can't do that. That y is the easiest one right there to get by itself. So y is equal to, I'm just going to subtract the 2z so that I have that y by itself. So y equals 3 minus 2z. So I want to type this in for y. So it's going to go in this middle slot right here or right here. And the one that you choose is the one that variable is contained in it. So I'm going to pick the one that has a z, and I would type this 3 minus 2z. Whoops, that's 3z. In that spot for y. Y is equal to 3 minus 2z. So I have the z here. Y is 3 minus 2z. And now I need x in terms of y. I need to figure out x equals blah with y's in it. So I'm going to come up, in terms of z. My bad. Sorry, in terms of z. We're doing this all in terms of z. So I'm going to use this very top equation. The reason I'm choosing this very, very top equation is because it's easy to get the x by itself. So I have x plus 2y minus 3z is equal to 4. Well, I decided a second ago that y is 3 minus 2z. So this is x plus 2 multiplied by 3 minus 2z. We're substituting that for y. Minus 3z is equal to 4. So I just want to get the x by itself. So I'm going to distribute the 2. And then I'm going to move all these other terms over to this side. So I'm going to subtract 6. And I'm going to add 7z. Whoops. 7z. So I get x is equal to 7z minus 2. So that's a negative 2 and a 7z. So this is going to go in that first spot, 7z minus 2. So when you finish, you should only have one variable, and it should be the variable that's in the box that you chose. So these both have a z in them. So we would have chosen this selection. We would type in our x and our y in terms of z, and the z is already there. So this is a little tricky. Hopefully you can work on this topic in class in case you have any questions. But it is a little bit tricky when it has infinitely many solutions. So let me know if you have any questions. Thank you.